Hello friends! You can see the reviews of different devices on my channel, but in view of its name, from the very beginning it was planned to review only the batteries and miscellaneous devices which are connected with them. And this video is dedicated to comparison of two devices which are necessary in case you build a power bank, a power wall, a simple battery pack, or for instance, if you repair batteries of power tools. Some guys try to solve this issue with the help of a soldering iron, but in case of overheat the batteries can be damaged. That's why it's much better to use spot welding devices. This device represents only a circuit board. Everything comes soldered except these two parts, capacitor and beeper. The operation voltage of this board is from 12 up to 14 volts, and in order to get excellent results you'll need to use 12-volt automobile battery. Now about this device. It's not the brother of this one, most likely the cousin of it, because of two differences. The first difference is that the operation voltage amounts to approximately 4 volts because of the second difference. The second difference is that the device has its own battery, which is a lithium polymer one, and the common capacity of the battery is 5.5 amp hours. But I requested to send me the device with double capacity battery for more reliability. Before we test the spot welding abilities of these two devices, let's disassemble the second one. Here we have really two batteries in parallel. Well, the boards are very similar. Here we have 5 MOSFETs, here only 4. And here the manufacturer added copper wires, which is really excellent because of high currents. Let's measure the internal resistance of the battery. 1.7 milliohms. And on the board, even 1.4. A great result. There is always the issue of internal resistance in case of spot welding, because none of the batteries with high internal resistance can provide high currents. Before I got these two devices, I watched some videos on YouTube which were dedicated to spot welding with the help of the car battery and the solenoid switch. Something like this. So minus goes to this wire and directly to the tape and the battery. The wire from plus contact of the car battery goes to this contact, and also this wire of solenoid switch is connected to this plus, and as soon as you press this button, this solenoid is on, these two contacts are connected, and plus from car battery goes to this tape and the battery. But after some attempts I refrained from using of this version, because the main disadvantage is that you can't control the time. Sometimes the tape is not welded to the battery, but it's not so bad. If the welding time is more than necessary, you may even burn the battery contacts. I had even 2 holes here in such case, so we will not consider this version in our review. Unfortunately, I have no car battery, but instead of it we will use 4 such batteries. 12 volts, 12 amp hours, and the internal resistance is 13 milliohms. The device has some modes. The first mode, 1 signal, two signals, three signals, and the red LED means that we have the 4th mode, the most powerful. Now this is off. As to this device, first mode, second mode, third mode, 4 times. Fourth mode. The fifth mode. The sixth mode. Again the first mode. Also, this device comes with a cable for charging. And in case of charging, we have something like this. Now it's time to compare the devices. First mode. First mode is very weak. The second mode. The third mode. So this way is much better than this way. And it's excellent. Even here we have holes. And in the most powerful mode, we can remove, but anyway, let's try once again. 1, 2, 3. Once again. Here we have holes. We can insert a needle. Here we have even a part of this tape. So this part is here. Sanyo battery, the first mode. Not sufficient. Second mode. Ah, it was terrible. And here we have a great hole. So it's pierced. You can see. So for great spot welding you should have considerable experience. Now the fourth mode. Okay. Anyway, it welds. LG. Let's check only the fourth mode. It was too far. No success. Maybe this 0.1 millimeter tape is too thick. Maybe the current is too weak. Now let's check this device. First mode. the second mode. So the signal means that the device measures the resistance between the contacts and is ready to weld. No. The third mode. No. We can remove. So the device anyway welds. Even a smoke. The 6th mode. Yeah, really. So the device welds anyway. But we will not remove the tape as soon as we weld. Sanyo. Also, here we have hole. Let's do it this way. Not successful. LG. Not bad. Once again. So anyway, we can remove the tape. But if you weld with such non-professional devices, you should weld in 2 or 3 places. Let's do it. One, 2, 3. However, not successful. It's much better. It's okay. So one welding is not sufficient. Maybe the currents should be higher for one welding. Okay, so you will not remove this tape, and in case of the power bank or maybe power wall, this spot welding will be sufficient in case of 3 welding points. And now let's do the same with this device. So the internal resistance is the key issue in spot welding. 1, 2, 3. It's okay. Sorry. So there's a problem for LG. On Sanyo. 1, 2, 3. So in case this one is okay, I can conclude that the internal resistance, which amounts to is much higher than 1.5. But this is a theory. Let's measure the internal resistance of this battery pack exactly here. 11.5, the maximum, and the minimum 10.3, 10.2. So in this situation, the main question is that the device with the less voltage, 4 volts, coped with the task, and the device with a power source of 12 volts somehow failed. The internal resistance of this battery pack is 7 times higher than the same parameter of this lithium polymer battery. And final test. There is no possibility to remove this tape. Not possible to remove. So we can see all the points, and here only the first one was strong. So here is the situation. And also a very important note. Let's check the pulse width of the signal which comes out from both boards. The first mode, 0.2 seconds. The sixth mode. Here the width is a bit more than it was before. Now let's check this board. The first mode, the same width, 0.2 seconds. Also 0.2. So we can say that the pulse width of the signal is approximately 0.2 seconds. And finally, about the advantages and the disadvantages of the devices. The advantage of this device is that it's really cheaper than this one, but for proper operation it requires either car battery or 12-volt lithium polymer one. So this device becomes almost portable. As to this device, it's completely portable and requires no additional battery for operation. 8 centimeters, 4 centimeters, 14 centimeters, 8 centimeters, 4 centimeters. The approximate weight 100 grams, less than 460 grams. So I can conclude that despite the absence of car battery, this device will definitely cope with its task when connected to the battery of very low internal resistance. So both devices are acceptable and you can use them for battery connection. Thanks for watching. Wish you good luck.